welcome again. Today we are going to discuss about the computational mathematics concept number 21, example of Newton-Raphson methods. Here the given question is find the root of the equation sin x is equal to 1 plus x cubed between -1 and -2. Correct up to 3 decimals placed by Newton's Raphson methods. So now solution. Here, given function is f of x is equal to x cube minus sin x plus 1. So, its first derivative is f dash x is equal to 3x square minus cos x. Since the initial guesses are given, that is -1 and -2, so our interval becomes -1 comma -2. Also, here n is equal to 3 because of after 3 decimal places. So now we can calculate error. So error is equal to 1 by 2 into 10 power minus 1. So we get 0.499 our error. Now by using Newton-Raphson methods, we have xn plus 1 is equal to x1 xn minus f of xn divided by f plus x xn. Let x1 is equal to -1 be the initial approximation root, because here uh, already initial guess is given. So otherwise we have to calculate the initial guesses uh, to satisfy f of a into f of b is less than -1. We have to choose a and b such that this expression is holds. So in our questions, initial guesses are already given, so we can let x1 is equal to -1. Then by Newton-Raphson methods, we have x2 is equal to x1 minus f of x1 divided by f dash x1. After putting the value, we get -1.3421. This is our second approximation root. Also, x3 is equal to x2 minus f of x2 divided by f dash x2. So this x1 becomes x value of x2. After calculation, we get 1.2565. Okay. Now x4 is equal to x3 minus f of x3 divided by f of x3. Okay. After putting the value of x3 here, the value of x3 becomes value of x2. So after calculations, we will get -1.249. So, what? How we can confirm this is our root? We can confirm that by using by calculation the error. That means absolute value of x4 minus x3 is equal to 0.75, which is less than our error. So our final root is -1.244. Therefore, root is equal to -1.249.